So a wonderful good morning, dear LinkedIn community and composites launch experts, composites experts out there in the whole world. We have today a IMBEO's and Composites Launch in cooperation with Composites Launch. I'm proudly presenting JEC Forum DACH in Augsburg. And in order to warm the whole session up, I am proud and honored to introduce you to the 5 finalists of the JEC DACH Forum Booster Startup Challenge. What a long name. And welcome with me the 5 finalists here on the screen, dear community. Here we go. Everyone's here. And I will introduce you to the gentleman and the lady, Nazanin. Ladies first, of course. I will move her picture also in the right-hand side of myself. Nazanin Saidi from BIOwerkz. She will introduce, of course, and pitch her startup idea soon. Then I'm very amazed and delighted to welcome Thijs Rosso from South Africa. So yes, you hear it right. We are as far as South Africa today. So usual flight time from my place here to Johannesburg is about 8 hours. So that's quite a distance. And I guess you are running right now into summer, Thijs, and we are running into winter. Then we got in clockwise Guillaume Perben, who is talking about composites recycling. Then we got Daniel Schuster. Guillaume, from where are you?
Lausanne, Switzerland.
Lausanne, Switzerland. Okay, so we got the DACH realm also covered here. And then we got Daniel Schuster from Kassel, Germany. And Ruben Brouwers, I'm assuming you are from the Netherlands, Ruben. And
yeah. But I know we are in Hanover, Germany.
In Hanover, Germany. Okay, wonderful. Good. So this is the first round of introduction. So how will this work today? It will work like this. Maybe you've watched my last Startup Booster Challenge that we made here. This is an interactive show, of course, that I really love with LinkedIn, that you can go live and have the audience participating in the discussions. So whenever you are watching live here right now, I have 2 questions and 2 requests from you. The one is, can you hear us and can you see us in a good manner? Let us know, because in a live stream it's always a technical thing. It can go wrong, you can't hear us or things like that. And if we can get your feedback timely, then we can adjust maybe some of these settings. So that would be one thing I would ask you, that someone just writes whether we can be heard and seen. And then secondly, please introduce yourself, community. Please let us know from where are you tuning in. And I want to know this because I want to see the reach. Right now, our panel is from Germany, Netherlands, down to over Switzerland, down to South Africa. So we are spread quite far away, but we are all in the same time zone, luckily. So write down from where you are tuning in. And if you can't stay all the time on this live stream because you have other commitments, obviously, you are covered. This will be recorded, and as in the minute where I press the stop button, you can watch the whole broadcast in the replay once again. So don't worry, just come back at any time you feel this will be important. So startups are, of course, the seed of an economy, and this is why I always support startups. And this time in conjunction, of course, with JEC Forum DACH, which is an arm of JEC Group. You know JEC from JEC in Paris, the JEC World, the huge exhibition. This is why we do this in parallel, and maybe that's also a good time to show you the how they call it, the thumbnail of JEC. I will just show it and display it shortly so that you know where we are coming here from. So this is the startup, and you see this is the JEC Composites Startup Booster. So if you don't have your ticket yet, it is on the 29th and on the 30th of November. So get your tickets under JEC Forum DACH. Just Google it and you will find, of course, your ticket. So startups are important, are the seed of the economy, and we are starting now one after the other first with an introduction round, not the pitching on the solution yet, please, everyone. And I would ask Nazanin first on stage and ask her to formally introduce herself about, you know, your job, your current role, what is your mission with this startup before you come in the second round and introduce then your startup idea. Let's do first a formal introduction. Nazanin, stage is yours.
Sure. Good morning, everyone. My name is Nazanin. I'm the CEO of BIOwerkz, and our mission is to close the existing loops in construction industry by developing new wood from no wood, only waste and mushrooms. We would like to have no organic waste on the planet anymore. That is our big vision.
Wonderful. Okay. Then we take Daniel to the screen. Daniel, introduce yourself, please.
Hi, good morning. Yes, I'm a co-founder and managing director of Cavicore, and we want to enable an eco-friendly way to manufacture hollow and complex carbon fiber parts.
Wonderful. Then next in line, we take Guillaume on the page. Guillaume, please introduce yourself.
Good morning, everybody. I'm Guillaume Perben from Switzerland. I'm the CEO and co-founder of Composite Recycling. Our mission is to make composite materials recyclable so we can reuse them and continue using them to continue innovating with those great materials.
Okay, wonderful. And then we got Ruven.
Good morning. My name is Ruven Brauers. I'm the CEO from the Buffer Technology and the inventor of HARDCORK, which is a composite product basically made out of fabric, cork, and bioresin.
Okay, wonderful. So and then we got Thijs, of course. Thijs comes to the picture.
Thank you. I'm the Chief Technical Officer at Microwave Solutions. It's a Swiss company based in Basel, and we have offices in South Africa. And our mission as a green tech is to recycle composite materials into the most valuable end products.
Okay, wonderful. So let me take everyone back into the screen. And yeah, it's a wonderful round here. And yeah, let me ask Nazanin first. Nazanin, are you excited to be a finalist in this startup challenge and booster?
Yes, of course. I'm very excited, and this is my first time presenting live. Also, it looks like Zoom, but it's a bit strange. But I'm very excited to be here. Thanks, Ilkay, for selecting us to be the finalists and to have the opportunity to present ourselves to the community that cares about sustainability and future of composite materials.
Yes, you're welcome. You're welcome. By the way, if you can stand a bit more up so that your throat is not cut by the lower third, then we can see your face much better. Thank you so much.
Okay.
Okay, then Nazanin, I would say we will start the round with you. Ladies first. You have prepared a pitching slide deck. So how this works is everyone will have now 3 minutes to explain us what their startup idea is. And I've given a sort of a structure to the participants, dear community. And the startup structure, the pitching should be this time. So I'm changing this from time to time. This time we will do it this way. We will talk about the problem first. So what is the problem that have been experienced and that the startup is, you know, catching now as an idea? And then what are the benefits? Yeah, of course, there might be a bridge that is the solution first and then the benefits. But I want to make sure that startups and innovators out there understand that benefits are the things that the customers drive really decision to buy. Yeah, and startups need to be sensible on being very customer focused and customer oriented, and that's the reason why I asked them today to focus really on the benefits of their solutions. Nazanin, so you have prepared a slide, and I will now bring this slide deck up to the screen. Yeah, yes. And I will remove myself, and I will now lean back like all the others and listen carefully to what you want to say.
Again, I will introduce myself again. Good morning, everyone. My name is Nazanin. I'm the CEO of BIOwerkz. We are trying to close the existing loops in construction and furniture industry by developing new wood from no wood, only waste and mushrooms. We started our research by looking into the major problems that industries are facing and the positive impact that we at BIOwerkz can make to mitigate those problems. The problems such as deforestation, waste management, and landfill, as well as the carbon footprint of construction industry. At BIOwerkz, we started to look into the solutions on how to transform and upcycle organic waste into wood from no wood with the help of fungi, the most underused resources of our planet that can potentially save us from the adverse effect of climate change. Mycelium, the root network of mushroom, which is always hidden in soil and wood, can drive the transformation of construction industry by acting like a binder, gluing all the pieces together, all the organic pieces together, making us independent of synthetic binders to develop a biocomposite that we call new wood. 100% bio-based alternative to traditional engineered wood product with advantages over these materials, especially in environmental aspects. New wood does not need additional synthetic binders. It does not need to use freshly cut trees. At BIOwerkz, we are aiming for about 2% market share of total engineered wood product market with a focus on engineered wood products, mainly particle boards, OSB, and MDF, which is currently valued as €2 billion. At BIOwerkz, it's very important for us to be in line with United Nations Sustainable Development Goals in environmental aspects through upcycling a lot of waste, saving a lot of trees, and also reducing the carbon footprint of material. We are aiming for goals number 11, 12, and 15. And in terms of social and economic aspects, through creating a lot of jobs, creating additional income for farmers, and also reducing the waste disposal cost for company, and through sustainable manufacturing, we are aiming for goals number 8 and 9. So far, we have made our mission possible through a real-life proof of concept and proof of value prototype. Our well-known microtree, which has traveled the world, is the first prototype showing the structural capabilities of mycelium as the future building material. And our mycelium wall in Batam House, a self-sustainable house in Indonesia, shows the strength and durability of new wood as the future building material. We have also received a lot of awards for our project. Recently, we were awarded by DGMB in Germany, and we have also been featured in many regional and international TV stations like WDR, CDF, and Arte. Now we are looking to raise around €1 million of funding, which goes to different parts of our production, from administration and equipment and assets. It may sound far-fetched, but ongoing pandemic taught us how fast we can adapt to the new concept, because without planetary health, there would be no wealth. So for those who act now, the long-term benefit could be substantial. And I would like to end my presentation with the quote of Woman, Life, Freedom. Thanks a lot for listening to my speech.
Wow, that was a wonderful ending, woman. Yes. We need more women in engineering. You are absolutely right. And this is also why Women in Composites, for example, of JEC, is such a great initiative right now. Nazanin, I have some clarifying questions, if you allow.
Sure, of course.
Unless probably I was too much focused on the production here with the live stream. Now, can you come back to me and tell me what is the problem that you are addressing one more time in 2 sentences?
Sure. So we are addressing two main problems with the current engineered wood product market. One is the problem with deforestation, because a lot of trees, almost 2 billion trees, are cut every year for construction and furniture industry. And the second problem we are addressing is the waste management and landfills, because the current composite needs a lot of synthetic resins, which also the engineered wood product seems sustainable, but they are not recyclable because they have a ton of chemical inside. So these are the main two problems that we are addressing with our invention.
Okay. Another clarifying question then for me is, because I just want to understand the concept fully comprehended. Your customer is probably not the land farmer, the forestry or things like that. Who is your customer? Who is your customer avatar? Describe me your detailed customer that you wish to have.
Sure. So basically our business model is a B2B business model. We are the customer of farmers, and we get our waste from farmers, from mushroom farmers, and also from wood factories. And our customers are construction companies, architectural and furniture developing companies. And because our model is a circular business model, we also collect the waste from these markets as the feed to BIOwerkz to produce more new wood for them, to close the loops. So basically our customers are mainly construction, architectural, and furniture industry.
Okay, wonderful. Now I got it. So I'm sure all the viewers, watchers, they have already understood it. Just for me, for my own clarification and understanding. Now it's absolutely clear. And then I would say, before I move on to Daniel, let me show you some of the comments that are coming in. Of course, the panel knows we got here Benjamin Deboucher. I hope I pronounce it the right way, Benjamin. If not, please accept my apologize. So Benjamin has in the background organized all these 5 finalists, and I'm very happy that we are teaming up here and doing a great job together. Then we got Herbert here. Herbert is a very loyal viewer. Thank you, Herbert, for tuning in and you being with me. And then Ruven is a very, very appreciative and funny guy. And you can see it, den Ruven finde ich gut, sagt er. Of course, they share the same name. Wonderful, Ruven. Okay, so we can be heard, that's fine. Then Benjamin makes a short introduction, of course, here. Yeah, so if you have any question, if you are a startup company, contact Benjamin so that you can see what's going on. Hi there, says Thomas Aschenbrenner. Hi there, just stopping for a coffee and quick check. I'm curious what the SUPs and ideas are about. Have fun and good luck. Thank you, Thomas, for tuning in. And Thomas also adds later on, interesting, although it's not my industry. And I can tell you what, I can tell you that what I'm doing here with these startups, with the exhibition centers and so on, what we do here is we create visibility for the sector. And I'm running, of course, on lightweight technologies and on composites. And I'm doing this now for 3 years on LinkedIn. And LinkedIn can boost your visibility and reach in a way that, in my opinion, no other media can compete with. Unless you are a celebrity and everyone knows you. Yeah, but we are not all this Tom Hanks actors in this world. We are hidden champions. We are middle-sized companies. So if you are in a sector, in a niche, in a market segment, and you want visibility, I urge you to look into LinkedIn. And if you want help, contact me, and I can get different branches, different sectors also being visible on this stage. So it doesn't have to be composites all day long, but this is the one I'm living for. So you got some more interesting on BIOwerkz here. Wonderful, Benjamin, for your assistance here. This is great. Alexander Glaber, Benjamin, they know each other. Nice, Alexander, that you are here. Then who else is there? Then we got Clotilde de Vallant. Well done, Nazanin, she says. Wonderful for your applause. Great pitch. Thomas says, Nazanin, great, love it. Also automotive industry and be an interesting target group for replacing plastics and wood in the interior. You see, all the ideas are already running in the heads, and this is why I love this interactive mode on LinkedIn. So thank you so much. Please keep on commenting. As you see, we will come back to all comments. Also, like some of you have already applauded or evaluated this, please carry on. Have a look in the details of this LinkedIn live stream in the description, and you will see that we are, evaluating also. Maybe if you can do it, and if you are brave enough, give on a scale of 1 to 10 a point. Yeah, let's try this. But be careful. Give 5 points already for the startups. Yeah, 5 points is the base for them being brave enough to come to me on my show. Yeah, so everyone earns already 5 base points, and then from 5 to 10 you can, tell the community what you think is the best idea. We are not evaluating the persons, we are evaluating the startup idea. Is that a plan? I don't know if it's a good plan or a good idea, but let's try. Maybe we can have some fun with it. Okay, so let me then introduce Daniel. So Daniel from Kassel, not so far from myself. A44, Autobahn, who knows Germany, knows A44. Kassel, Wilhelmshöhe, a very nice spot. And you got Hercules there, right?
Yes.
Are you local to Kassel, Daniel, or just being there for the job?
I'm local here since more than 10 years.
Yeah. Maybe you can explain why Hercules is in Kassel.
Why? Oh,
Yes.
That's a long time ago that anybody thought about why he should be here. But it's
Yeah,
good
then explain what Hercules is.
Okay, it's a big statue in the Berg Park. It's a really nice forest in Kassel, in Wilhelmshöhe.
Wonderful. Yes, I've been there. You can do nice photographs. It's very scenery, very romantic place. And Hercules is basically overlooking from the hill all Kassel. Yeah, nice spot there. Daniel, okay, without further ado, let's get into your presentation, which is Cavicore. And I will now share it on the screen. And yeah, go ahead. The stage is yours.
Okay, thanks, Ilkay. Yeah, we founded 1 year ago and are incubated at ESABIC Hessen. And I want to show you today how the challenges and our solution for the manufacturing of hollow and complex carbon fiber parts. These complex parts are typically produced in halves and bonded together, but that causes a seam that weakens the structure. And other options are the use of soluble materials that can be removed after the part is cured. And our water-soluble salt cores are a new and sustainable way to produce these complex parts. The shape on the slide shown on the left corresponds to the cavity of the final part. We get this 3D model from the customer and produce the salt core. And for sure, there are other soluble materials on the market, but they are expensive and unstable, especially at high temperatures. They are difficult to remove and require additional tooling, what is again time-consuming, expensive, and adds limitations to part geometry. And our solution is based on pure salt, mainly sodium chloride. It is by nature highly temperature resistant, up to 800 degrees. And it is also by nature 100% water soluble, what leads to reliable removal procedures. And we produce by machining. That means we don't need any tooling, and that saves the user time and cost, and also allows the design and the realization of complex components that were not economically feasible until now, especially for small series or even quantity one. And as mentioned, our process is based on pure salt and has a really low footprint. And we do not use any binders or additives. And that opens a wide range for recycling or reusing of the low concentrated salt water. And all this leads to a competitive price and to a more eco-friendly way to produce these complex and hollow carbon fiber parts. Thank you very much.
Let me get back to the screen. Yeah, Daniel, as with Nazanin, maybe I'm a little slow in understanding. 2 sentences. What is the exact problem you're solving?
Is the manufacturing of hollow carbon fiber parts.
No, that's not a problem. This is what you do. I want to know, what problem do you solve with it?
Yeah, it's a problem
the customer has a problem and you want to solve it.
Yeah, they have difficulties producing hollow, high quality parts.
Ah, okay. So you get more flexibility in hollow parts. Okay.
Yes.
So,
yes.
Yeah, because hollow parts, what is the difficulty of hollow parts? Can you explain that?
Yeah, it's difficult. If it's an easy geometry and you can just split it and produce 2 parts that are bonded together, it's an option. But it's always, the part has then a seam, that means it's extra weight, and it's not, the structure is weakened by this seam. So it's better to have it in a one piece. And for more geometrical difficult designs, the bonding of 2 halves gets quite complicated. So there's the need for soluble materials. And the solution from us based on salt has the advantage of being highly temperature resistant and water soluble.
Okay, great, Daniel. Now I got it. I'm totally with you. It seems that I'm a bit more distracted from presentations. When I hear actively, it's much better. So right now I'm seeing we have quite a number of live viewers, and I'm seeing only a few of them are commenting. I would like to know who are the other viewers. Please write in the chat. There's a chat down there from where you are tuning in. Just say hello, that's fine for me, because we want to measure the reach in which territories we are. Yeah, be brave enough, just write hello. Nothing happens, you will not be punished for that. Write it down so that we have everyone involved here. And then we got a question from Benjamin. Benjamin is asking you, and I would basically expand this question. Do you already have existing clients? And I would expand it in, and who is your ideal client, Daniel?
Okay, yes, we do have clients. We have two customers, and we have like 5 pilot projects that could be customers in the future. And our ideal project is really a difficult to produce carbon fiber part in a small quantity, where it's really expensive to construct the mold and the tooling up front, and that's the best case for us.
Mm-hmm. Okay, great. Then the next in line is, so thank you very much, Daniel. I will take off you from the picture right now, and I will greet now Composite Recycling, that is Guillaume. And welcome, Guillaume, from Switzerland, right?
Yes, thank you, Ilkay. Thank you very much.
Yes, good. Lausanne, you got a nice lake there, am I right?
Yeah, it's a little pool that we go swim in and sail on sometimes.
It's a little pool. I like your humor. Yeah, wonderful. Lausanne is also a boom town, and it's growing. A lot of investments there, right?
Yes, it's a very, very strong economically, and we have a lot of initiatives. And also, we're very fortunate to have the École Polytechnique Fédérale de Lausanne, which is a great science and R&D center with about 20,000 students, I think.
Wonderful. Okay. Now, Guillaume, I'll let you pitch for your startup first, and then I will come back to you with some specific questions, because composite recycling is a very, very, very hot topic. So everyone who is in the circular economy, listen to Guillaume.
Thank you, Ilkay. All right, so shall we get the... Thank you.
Yes.
So, like we were saying, I live by a big lake and we do a lot of sailing. And I am not just the co-founder of Composite Recycling, but I'm also a sailor. And I love the wind. I love the wind pushing my boat on the lake or on the Mediterranean. What I don't love so much is that my boat is not recyclable. And because the beautiful composite materials that make my boat stiff, light, absolutely amazing and high performance, well, those are not recyclable. And so with my team, we all sailors and we all love sailing, and we looked at why can we not recycle boats at the end of their useful life? And the answer, when you look around the composite world, is that, you know, recycling fiberglass is something that is not economically viable. The performance is not good. So the solution is, as on the slide, basically, well, landfill them and sometimes incinerate them. When you incinerate 1 kilogram of composite, you release 2.5 kilograms of CO2 in the air. We started using them about 50 years ago, and now they reach the end of their useful life. And when you start pulling this little problem, you find that it's not just our boats. It's all, as you know, the wind turbines, the interior fittings of airplanes, the trains, and everything. We thought maybe we can do something about this because landfill sites are filling up. Incineration is worse. We absolutely needed to do something. So we look back at how is it that it's not recyclable, and all the attempts that have been done. There's been some carbon attempts as carbon fiber recycling with solvolysis, which is chemical, but we felt maybe we could use something else like pyrolysis. And when you look at pyrolysis, most of the attempts have been done with generic machines, and they can recycle tires, plastics, and everything. The problem with this is that you need to shred everything in advance so you get a consistency of temperature in the chamber. And when you use this shredded materials, the fibers that you get outside after the reactor, they're very small, so they cannot be reused. So if we can switch back to the slide, please. We switched to smart pyrolysis, and we decided to specialize in composites. Our machine can only do composites. So what we do is we heat without oxygen. This is pyrolysis, everybody knows that. But our chamber is static. We do not shred. We do not move anything inside the chamber. So as you see on the pictures, the fibers stay absolutely intact. The plastic part of the resin becomes gas, which we use to power the unit, and oil. Pyrolysis oil is used by the chemical industry to make decarbonated plastics. Then we're left with some fibers, but as you can see on the photos, they're not exactly clean. So we have developed with the École Polytechnique Fédérale de Lausanne a post-treatment where we clean the fibers and we can recombine them with new resin to make new composite materials. Those fibers are sellable. They can be sold and reused, particularly to make glass fiber mat, for instance. And because we don't want to start transporting bulky wastes like boats and stuff like that, our treatment unit fits in a 30-foot container, so we can move it around and come treat on site. So we're closing our funding round. We are industrializing the solution, building the first container, and we're scaling up now. Thank you.
So that was very, very impressive, Guillaume. And I really see that you are the experts in, recycling. You are in the domain of recycling, we can say, not upcycling. It's recycling, is it?
When you treat waste, the danger is to wait until you have the absolute perfect solution. We decided, for instance, if you want to redo textile roving fibers, you need to melt them, and then your carbon footprint is not good.
Yes.
So we focus on redoing matte. For now, we will do roving at some point, but now we do matte, which is the non-structural applications. It's 50% of the market of glass fibers. So we feel that's a good start.
Yeah. So in order to reuse the fibers in a textile process, like in non-wovens, needle mats, what about the sizing of the fiber? Do you remove the sizing and then reapply, or you take it as is?
No, the sizing is removed anyway by the pyrolysis. When you go to those temperatures of 400-500, it is removed. We have teamed up. We have two very large and very known industrial partners. One of them is a weaver, and they are looking at the best applications to start with, and that these applications condition the type of surface treatment that we do. But we do surface treatments for some of the fibers, yes.
Okay, but
and for some we don't need to actually.
Yeah, exactly. What I wanted to say, my understanding is you don't need much of, you know, for this kind of matting, you don't need a sophisticated sizing. Yeah.
Yeah, exactly. And the great benefit we have of working with the Advanced Composite Laboratory of the EPFL is that we found very recently that the flow properties are excellent. So you know you can use this, for instance.
Mm-hmm. Okay. Do you see in glass particularly any properties being, you know, reduced? I mean, glass is in percentage, weight percentage, over 50% SiO2, silicium dioxide. Then we got magnesium oxide, aluminum oxide. These all are, you know, natural elements. Is there anything that is that the inorganics stay in place? Is there anything that will reduce mechanical properties or temperature properties?
Yeah, so first, remember one thing is that when you talk about recycling, you have all types of waste. You have 50-year-old boats, and then you have production waste that is brand new, actually. Yeah. So obviously, the glass has been aging in a different way. And again, we do matte. So structural properties are not such a focus, but our scientists just love going for the closest they can to the properties. In terms of what we have now is about 10 months ago, we were at 50%. Now we're at 93% of mechanical properties. Mm-hmm. But that's if you use 100% recycled, for instance. We also need, the market tells us, we have an industrial partner who's actually using composites to make new pieces, very big pieces. And they tell us, I don't care if it's 100% recycled, give me 10, 20. And what we found out is if you do a hybrid, virgin 50, recycled 50, the property is 99%.
Yeah, absolutely. I mean, there's no rule to say you have to be 100% recycling or you have to be 100% virgin fiber. Yeah, why not blend it? Very, very good idea. Very good idea. Yes.
It's you know, Ilkay, the thing is, we shouldn't be dogmatic. We should try to be efficient. So
yes,
if it's the hybrid that works, let's go for it.
Yeah, absolutely. So let me check what the community says. So we have someone from Singapore today here, Ali Reza. So our reach is quite far east, South Africa. Then we got Carsten is tuning in from Munich AirTech. Wonderful. Okay, yeah, Munich AirTech in parallel right now. Alex Len from Paris. She's also one of the project managers. JECs. Wonderful that you are tuning in. Then what we have, Nicolas says hello from Stade. Okay, Stade. I've been to Stade 2 weeks ago with the CTC's 20 years of jubilee. And then Benjamin says, great solution, he loves it. So you have a fan here. Who will be the clients of your container? For which applications have you used the recycled glass fiber? Yeah, exactly. That the second part is an interesting one. So start with the customer first, and then let's move to the application. Do you have a very exotic application that you can illustrate us?
Actually, okay. So first for the container, because we like boats, we started with boats. You know, better start where you're having fun. And so because the French have a very, very large boat building industry, they're also the first ones to have built deconstruction centers across the country, 26 today and soon 44, where people can actually bring their old boats and they remove the metal, they remove the wood, and then they're left with the hulls, which is interesting for us. So we're now partnering with the Fédération des Industries Nautiques in France. And these will be the first places where our containers will be, and also the production waste for the boating industry. Now, the more we work on this, the more we find there are businesses that don't have thousands of tons of production waste, but need to have their production waste treated. And the container, obviously being mobile, can do this. So these are our first clients. Then we also have, that's for the end of life. And also we have clients for the oil and for the recycled fibers. These are very large and yeah, as I was saying, very known actors of the sector. We're partnering up with them now. So industrializing is a different talent that we do not have, and they do have that talent. So we're complementary.
Okay.
What was the next question?
The application, but this is basically what you've mentioned. Yeah. You've covered both. You've covered both in your explanation. Thank you so much, Guillaume. So time is running. Now I will take Ruven on stage, and you will be free for now, Guillaume. Have a cup of coffee. Thank you so much. Ruven, thanks for joining and tuning in. Yeah. So let's talk about HARDCORK. Yeah. HARDCORK, I've mentioned it in the details, is your solution, but the company is Bufo. Maybe you can explain us about Bufo and HARDCORK. How does that embed in your profile and into your portfolio?
Yes, I can try. I'm a professional surfboard and skateboard builder by trade. So that's what I'm doing for 35 years. Pretty much what everybody knows, skateboard. There's a surfboard in the back. Wow. And surfing and skateboarding, especially nowadays, is including a lot of jumping, a lot of hard impacts, and lots of vibration. So I have the idea of putting core into the product in order to get better damping properties, which is much better, of course, for tough landings or in skateboarding, even on the normal vibrations. So I started using a cork mud and tried to make a board out of it, and it broke pretty much in the same second when I stood on it. So I was thinking about how can I improve the strength of cork, and started to mix the cork granulate together with a short fabric, which is going around the cork granulate. And all that is getting compressed together with a bioresin. I've got some example here.
Oh yeah, show it closer to the camera, please.
So this is pretty much where it's all starting with.
And can you take it in? Yeah, pour it, so we can see the consistency.
Yes.
Pour it, yeah, exactly.
You can even see the fabric there.
This looks like tobacco.
Yeah, and it's non-toxic, so it's a pretty nice material to work with. It's just a bit thick.
Good.
But to make a long story short, in order to get the shear strength, which we need for skateboarding and for surfing, I added different kind of fabrics, starting with carbon. Later on, I switched to a more biological approach, and nowadays we're using basically Hanf and flax fabric. And the product is very versatile due to the fact that we're using cork granulates from 0.1 millimeter up to 5 millimeter, so you can make a lot of different products out of it. Could be a surfboard or a skateboard. Right now, we are basically concentrating on sandwich plates. You can make furniture out of it. It also works very great in boat building, automotive. So here's another example. So this is a chair with very drapeable material and very easy to use. And coming back to the mix, we're using a biological-based resin system. So we only have like 3 components. You've got the cork granulate, the fabric, and the bioresin, or bio-based resin. And the great thing about it, it's very easy to clean, because I'm coming from epoxy, and if you're mixing epoxy with fabric, you need acetone to clean all the mixing machines, and it's a very toxic operation. And in our case, we need some temperature to make it harden out, which is like 120 degrees minimum. But the raw mix can stay here easily for 4 weeks. So it's very easy to work with compared to normal epoxy systems, for example. Because if you mix, you have got a certain amount of time where you have to work with material, otherwise it's going to be too late, the pot life time. So our pot life time is up to 4 weeks easily. You don't need cool storage, and we can clean the mixing machines just with water.
Okay, wonderful. So I've taken now your website on the screen. Is there anything that you can show us regarding your startup idea here in the website?
Due to a lack of time, we didn't really could get that done on time.
Okay, so this is the landing page, but you will enlarge this with some more information, right?
Yeah.
Okay, great. Good. So, what about foil boards? Are you in that business also?
No, I'm concentrating on normal surfing. That's pretty much where I'm expert in.
Okay. So, how is it, the foil boards and your board people? Are you in competition to each other, or would you say this is more of a complementary sporting type?
We are not in competition at all, I would say, because on the foil board you're normally more outside on the little bit weaker waves, while on normal surfing you're always looking for the most dramatic and hollow waves possible. Okay,
wonderful. Good. Thank you, Ruven, for attending and showing us your startup idea. So please, people, rate the startup idea with this wonderful bio solution, and I liked it a lot. So write it down there what you think, guys, and if you want to know more about it, Ruven is certainly for you guys available. Then I will take next in round will be microwave solutions, and that's Thijs, our gentleman from South Africa, and I say bye bye for now for Ruven. Ruven, you will be coming later again into the picture. So Thijs, Pretoria at this time is a wonderful spot, isn't it? The trees are colorful, the summer is coming up. How are the vibes right now in Pretoria?
It's lovely this time of the year. It started to rain. We only get summer rains, and all the trees have flowers on them. The jacaranda trees are all purple, and Pretoria is very famous for the purple jacaranda trees in October.
Good. So you've prepared also a pitching deck?
Yes.
Which is this one, and I would say the stage is yours, Thijs. Show us about microwave solutions.
Thank you, Ilkay. So the problem with composite materials is how to end their life in a useful manner. There are problems with disposing of the material because all the composites are different. There's carbon fiber, glass fiber, there's different types of resins that they use. Some materials have metal parts or foam in them. So you need a solution to recycle these materials that is agnostic to the material, doesn't mind what type of composite it was. And also you don't want pre-processing because it's a lot of effort and a lot of energy, and it's not good environmentally either when you start cutting up composite materials or shred it to get it into a recycling system. And then the resins, there are polysets and the thermosets and thermoplastic resins. There are different materials and they have different properties. And you really need a way of getting the resin and the fiber separated in a way that you can get the maximum value out of the polymer part. And then obviously always you need something that is energy efficient and with a low carbon footprint. So knowing what those issues are, we have a technology that has these benefits. We can, with our microwave recycling systems, we do pyrolysis in a structured way where we can selectively depolymerize the polymer part of the composite. So we can break down the resins into valuable components, valuable oils and gases that can be collected. In the case of polyurethane, for example, we can recover a high percentage of aniline, which is the building block for making new polyurethane. So it is circular in that way. that we can break polyurethane down to the building block needed to make new polyurethane. At the end of our process, all the polymer has been removed, the resin, and what remains is the fiber. And we have found for both carbon fiber and glass fiber that the fibers are completely intact and undamaged. And because our system doesn't rely on the shredding of the fibers, we can put the entire components, even in full scale entire wind turbine blades into our system. You have the full fiber length. It is not shredded, so you have the maximum options of using it. And we have seen that the fibers are clean and undamaged. And these fibers can then either be reused as fiber or the loss on ignition, which is basically the amount of char on the fiber, is at less than 0.5%. So that is low enough for the glass fibers to be returned into furnaces and melted up to produce new fibers, if that is the preferred way of doing it. So we have both options of reusing the fiber or cleaning it enough that it can be melted up again. We don't lose the coating, the sizing on the fiber as well. And not only can we recover all the components, we can process the gas portion of the polymer into carbon nanomaterials. And that is what we do. Thank you, Ilkay.
Yeah, thank you so much, Thijs. That was a small delay now, but we had some tone issues because of the distance. But I guess in the replay it will be very nice to listen to you. Very interesting solution. Thank you so much for the presentation. So we got one question from Benjamin. Do you recycle any kind of composite materials? He's asking. What would you say to that?
Yes, our process is material agnostic. We can process any type of composite material, even those that are still loaded with metallic inserts or foam filled, carbon fiber, glass fiber, any composite materials.
Okay, great. So then, thank you so much, Thijs. Then I will take Nazanin into the picture, Daniel into the picture, Guillaume and Ruben for our final round. We are on time. So dear community, if you have switched on this live stream or joined our live stream at a later stage, we have been, or the startups, 5 finalists of the JEC Forum DACH have pitched their startup idea. So anyone, this is now outside the composite industry, who is in innovation, technology, in startups, please have a look at this show, because you can learn so much from the different kinds of pitchings that we showed we showed you today, presented you today. Today we didn't do a classical elevator pitch for each one, because that they have already fulfilled. This time we've talked about the problems they're solving and the benefits that are coming with them. That was the full focus here. So thank you very much for everyone. And as I said, if you have joined later, just watch the full broadcast from the beginning. It will be available within a short time.